All right, so we are moving on to 5.3. We're going to be talking about scatter plots and lines of best fits, okay? So with the scatter plot, we have dots that are on a plot, okay? And the first one we have is a positive correlation. So as you can see, with those dots, if you were to draw a line of best fit, you can see that it's going up, okay? Then we got a negative correlation. This is when if we draw a line of best fit, which we just try and draw in the middle, we can see that it's going down. So on the first one, it was going up. This negative, it's going down. But then for the third one, when it says there's no correlation, that just means that we can't really tell if there's a positive or negative. There's just kind of dots all over the place. So that's when your x and your y are not related. So there's no pattern in the data. And then for negative, as your x increases, your y decreases. So your cluster slope is downwards. And then on that first one with the positive slope, it says as x increases, our y increases. Okay, so as our x goes up, okay, so as we go further with our x, we can tell that our y also goes up because that line is going up. Some other words that we know are outliers. That's when we got some points that are pretty far from our line of best fit. So for example, if I had a dot right here, that would be considered an outlier. So on this first one, okay, for example 1, it gave us this table right here. We've got our x and we've got our y. This is going to be your first problem on Alex. So what you're going to do is you're just going to graph these ordered pairs. So even though there's two numbers, that's just going to be one dot. Remember, that's our x and then our y. This is an ordered pair. It goes x, comma, y. So for this first dot at 5, comma 7, my x is at 5. So I'm going to go to 5, but then my y is 7. So then I got to go up to 7, which would be right there. So my x is 5 and my y is 7. Next up, I got 8, 9. So my x is at 8, and then my y is at 9. And if you want, you can draw a line just so you know that you're on that 8, and then put a dot at 9. Just make sure you erase your line. Next up, 9, comma 11. So I go over to 9 and then up to 11, which would be right there. So I'm going to put my dot and then erase that line. Next up, 10, comma 8. So I'm going to go over to 10, but then I'm only going to go to up to 8 this time. Which would be right there. And then again, if you're drawing that line, make sure you erase it. Next up, we got 13, comma 14. So my x is 13, and I got to go up to 14. To be right there. Go ahead and make that dot. Erase your line if you drew it. Last one, 14, comma 12. So I'm going to go to my x is 14, and then my y is at 12. Again, this isn't very hard, but it's easy to mess it up. If you just put one of these dots in the wrong spot, it's going to count your entire problem wrong, okay? So be careful when you're graphing these dots, because you're going to get really mad if you get on Alex and it says it's wrong because you put, instead of like your first dot putting where it's supposed to be, let's say you accidentally put it here and I just marked in blue, it's going to count that whole thing wrong. So just be careful, okay? Some of y'all try and zoom through it, okay? Slow down, make sure you're putting your dots in the right spot. Also, it might help to check mark them off after you've written them so you don't do it multiple times, you know where you're at. So that's all your first one is. You're just plotting those 6 different dots. So then on this one, we can see that there's a pattern, okay? We have a positive correlation because normally as the age in years for our tree, that means it's getting taller for the most part. Table, or the next one, example number 2. Now we're going to sketch the line of best fit. So here it says the data points on the scatter plot below Show the theater revenue and the rental revenue generated by each of the 21 movies. Draw the line of best fit for these data points. It doesn't have to be exact line of best fit. Just draw your best approximation. So what that's saying is it doesn't have to be perfect. There's a lot of different correct answers. Just try and make it to be in the middle, okay? So obviously, this right there, that would be wrong, okay? Make it to where you're trying to get in the middle, okay, which would be somewhere around there, and there's your line. Okay, again, it doesn't have, there's not just one right answer, but it's got to be pretty close. It would not be something like that. See how it's not really touching many of our dots? So that one's easy. Just make it go in the middle of all those X's or all those dots. Again, this is the same thing. Now we just got a negative, okay? So this is a negative correlation, so our line will look something like this. Again, there's more than one right answer. It could be something like this. It could be something like there's a lot of different correct answers technically, okay? All you need is one, and it's got to be going somewhere in the middle of there. All right, next page for example 3. And if I'm going too fast, remember, you can pause it and then draw whatever notes you want to put on there, okay? All right, next up. Example number 3, scatter plots and correlation. So remember, that correlation is just saying if it's related. So if we have a negative correlation, a positive correlation, or no correlation means that it's not related. It's just a whole bunch of random dots. So for example number 3, the scatter plot shows the weight and fuel efficiency for each of 21 vehicles. Also shown is the line of best fit for the data. Fill in the blanks below. So we got our chart right here. Our X is the weight in pounds. Our Y is the fuel efficiency. And then it tells us that it's in miles per gallon for the fuel efficiency. And then it says that the weight is in pounds. So for these 21 vehicles, as the weight increases, hold on.
You need to report to the comments by 3. All baseball players, please report to the comments by 3 p.m. Have a great day.
Okay. So for these 21 vehicles, as the weight increases, what happens to fuel efficiency? Okay. What does it tend to do? Is it increasing or is it decreasing or does it stay the same? Well, that line is going down. So as our weight increases, our fuel efficiency, it is decreasing. Okay? Part B, it says, for these 21 vehicles, there is blank correlation between weight and fuel efficiency. Since that line is going down, it's a negative correlation. And then using the line of best fit, if we were to predict that a vehicle weighing 4,000 pounds would have a fuel efficiency of approximately what? Okay, so what we're going to have to do is we got to go to our graph, and we got to go to 4,000 pounds. So 4,000 pounds would be right here. How much is that fuel efficiency? Well, it's about 25. So approximately just means like about, around. Well, which one's going to be closest to 25 of our options? 12, 24, 30, 36, or 42? Well, we just said 25, so the closest to that is 24. And you can even see in our line, it was just below 25, so 24 makes sense. Next up, we got another one, but this time we've got a positive correlation because its line is going up, okay? So for these 21 students, as the number of hours increases, the amount of money spent tends to increase. So the more hours worked, therefore you're getting paid, or the amount of money spent on entertainment is going up. So part B, it says, for these 21 students, there is a correlation between the number of hours worked and the amount of money spent. So if you're working more, you're probably going to spend more because you got more to spend. That's going to be a positive correlation. So as you can see, if it's increasing, it's a positive correlation. If it's decreasing, it's a negative correlation. And then here we are, we're going to use the line of best fit. We could predict that a student working 8 hours would spend approximately how many dollars? So we got to go back to our graph and we got to go to 8 hours worked. 8 hours worked, we're going to draw a line up from it. And then we're going to go over. Well, that's just above 20. My guess would be around 22 or so. Oh, looky there, we got a 22. So working 8 hours, you're going to spend approximately $22 according to that graph. So we had a negative correlation and then a positive correlation. So just remember those patterns. If it's going up, as our x increases, y also increases. If it's a negative correlation, as our x increases, the y decreases. And then if it's all over the place, you can't tell where to draw your line, then that's no correlation. Example 4, predictions from line of best fit. So the scatter plot shows the time spent studying, x, and the midterm score, y, for each of the 24 students. So let's think about this. If you spend a lot of time studying, you probably should get a better midterm score, so just test score. So the more time you spend studying, the better score you're going to get on your test. And then this data supports that, because you can see someone that only studies for 6 hours get a lower score than someone that studies for 18 hours. But here it gives us the equation for this line. It tells us to use this equation of the line of best fit. So we got y equals we got y equals 3.8x and then plus 15.80. For an increase of 1 hour in time spent studying, what is the predicted increase in midterm score? AKA, what is your slope? Well, each hour that we spend studying, on average, we're going to go up 3.8 on our score. So therefore, it's 3.80. Part B, what is the predicted midterm score for a student who doesn't spend any time studying at all? So if you don't spend any time studying at all, you would plug in a 0 for your x, which would cancel that out. Therefore, your score would be 15.80, also known as your y-intercept. And then part C, what is the predicted midterm score for a student who studies for 12 hours? So what you're going to do is you're going to use that equation. You're going to use 3.80, and you're going to multiply it by 12, because you got to plug in for 12 hours, and you got to add your y-intercept at 15.80. So if you plug that in your calculator, you're going to take 3.80 times 12, and then plus 15.80. That's going to give me 61.4. Next up, the scatter plot shows the average monthly temperature x and the monthly heating cost y for each of the 24 months. So again, this makes sense. As it gets hotter outside, so as your monthly temperature increases, the amount of money that you spend on heating is going to go down, because if it's hotter outside, if it's 80 degrees outside, you're not going to be running your heater. So we got, what is the predicted heating cost for a month with an average temperature of 0 degrees Fahrenheit? So you're going to plug in that 0 for x, which cancels that out, right? Because anything times 0 is 0. Therefore, okay, it's going to be, our answer is our y-intercept, which is 97.20. So that's going to be our predicted heating cost for a month with an average temperature of 0 degrees Fahrenheit. Next up, for an increase of 1 degree Fahrenheit, what is the predicted decrease in monthly heating cost? That is our slope, okay? So therefore, it's going to just be 1.22. Since it already has the decrease, you don't have to put a negative. And then question C, what is the predicted heating cost for a month with an average temperature of 45 degrees Fahrenheit? Well, we got to plug in that 45 into our equation. So you're going to take your negative 1.22 times 45 and then plus your 97.20. Then you're going to type that into your calculator. Negative 1.22 times 45 and then plus 97.20, and you're going to get 42.3. And since we're talking about money, go ahead and make that 0.30. All right, so that is the end of the notes for 5.3. We will have an Alex on this tomorrow, Wednesday, all right? All right, I'll see y'all tomorrow. Bye.